Welcome to Effective Teaching and Learning for Secondary Science. This is Module 6.1. In this module, we'll focus on discussion and discourse in the science classroom. An examination of discussion and discourse is important, as studies suggest that question and answer sessions encompass roughly 80% of the communication that occurs in secondary science classrooms. That is, 80% of communication that occurs in the secondary science classroom typically follows the IRE sequence of initiating, responding, and evaluating. In other words, the bulk of communication follows an approach that requires memorization and regurgitation of memorized material, with teachers continuing discussion only until a student answers the question correctly, at which point the teacher then moves on to the next question, thus making the assumption that if one student answers the question correctly, then all students have learned the material. So, is this approach effective? Of course not. It is considered non-effective as it limits students' abilities to understand science concepts as they perceive learning as a search for right answers, and thus results in only superficial learning. Therefore, students, when engaging in this type of discussion, are not required to engage in higher order thinking. And when students are not engaged in higher order thinking, the chances for meaningful knowledge making to occur decrease, resulting in decreased levels of learning, and many would argue, lack of engagement. As Tweed 2009 reminds us, to be effective, students need to participate in interactive dialogue with the teacher and with one another. Likewise, in order for students to engage in meaningful knowledge creation, especially in the science classroom, they must come to understand the ways of sense-making that are characteristic of scientific communities. What is meant by this statement is that science is a social subject, and thus, science learning is a social activity. Consider how scientists function in real-life situations. They function in collaboration with one another, which of course requires effective communication. So if we view science learning as a social activity, then we'll also realize that discussion and discourse is supported by a learner-centered approach. With this in mind, let's consider the four basic kinds of communication: dialogic, authoritative, interactive, and non-interactive communication. Dialogic communication involves strategies that utilize more than one point of view. In other words, more than one voice is heard as a variety of different ideas are explored. Thus, this type of communication takes into account students' voices, students' ideas, opinions, and so on. Authoritative communication involves strategies that focus on just one point of view. In other words, only one person's ideas, thoughts, or opinions are explored, and there is no exploration of different ideas. Oftentimes, the authoritative approach examines the scientific point of view only. Interactive communication involves strategies that utilize talk that occurs in all directions. In other words, the communication includes talk between the teacher and the students, and between students flowing in both directions. Non-interactive communication involves strategies that utilize talk that is unidirectional. In other words, the communication comes only from the teacher to the students, or from a student to other students, but not in both directions. Here it's also important to consider the importance of matching the communication approach with the teaching purpose. So, how do we best utilize discussion and discourse in the science classroom? Well, we can start by teaching students to pose science questions rather than just answer questions posed by the teacher. And how do students learn this? Well, by teacher modeling. Thus, it is essential that the teacher explicitly teach students how to engage in scientific discussion and discourse by utilizing this type of language his or herself. As Chapetta and Kabbalah 2010 remind us, talk and argumentation are central features of sense-making in scientific communities and must be central features of science learning in middle and secondary schools. One of the major ways in which teachers can model appropriate use of communication in the science classroom is through the use of scientific argumentation. The National Research Council, as cited in Chapetta and Kabbalah 2010, defines scientific argumentation as logical discourse whose goal is to tease out the relationship between ideas and evidence. Thus, scientific argumentation is not a debate, but rather the communication that uses logic and follows the nature of scientific reasoning. Another way that teachers can model appropriate use of communication in the science classroom is through the use of talk moves. Talk moves are teacher questions and statements, as well as periods of silence, that encourage detailed student talk and foster student cognitive engagement. Examples of talk moves would include probing and redirecting. As cited by Chapetta and Kabbalah 2010 on page 184, probing is when teachers encourage students to extend, clarify, and justify their talk, whereas redirecting is when teachers encourage students to extend, clarify, or justify the talk of a classmate. Another way that teachers can model appropriate use of communication in the science classroom is through the use of talk formats. Talk formats include the creation of collaborative groups, peer pairs, and other group strategies that encourage engagement, thoughtful reflection, effective discourse, and thus meaningful knowledge creation. Likewise, if we truly consider social learning theory, and specifically Vygotsky's viewpoint of the importance of social interactions to learning, we must also recognize that we learn best when we move from learning in social context and move to individual understanding. So, one of the goals of discussion and discourse is not only to have students engage in communication, but to also construct individual meaning. So let's look at some ways in which teachers can model and teach students to utilize effective discussion and discourse in order to encourage thoughtful learning. Chapetta and Kabbalah 2010 provide some great discourse patterns and examples for us to review in preparation for actual practice. Let's take a look at their suggestions. One discourse pattern that teachers can use is the I think blank will blank pattern. An example is I think the metal will emit an orange color when placed in the flame. Thus, the function of this language is making a prediction. Another discourse pattern that teachers can use is the blank had blank, so blank format. An example would be the plants had received no water for 4 weeks, so they died. The language function served here is relating cause and effect. Another discourse pattern is the blank is the blank because blank. For example, the substance at the bottom of the beaker is a salt because a salt forms when an acid reacts chemically with a base. Thus, the language function utilized here is drawing conclusions. Another discourse pattern is this blank is similar to that blank because both blank. For example, the forelimb of the bat is similar to that of a human because both have the same kinds of bones, humerus, radius, and ulna, thus serving the language function of comparison. Another discourse pattern is the following. This blank is different from that blank because one has blank and the other does not blank. For example, eukaryotic cells are different from prokaryotic cells because eukaryotic cells have a nucleus and organelles, and prokaryotic cells do not have these components. This serves the language function of contrasting. Another discourse pattern is the following. The main idea from this observation or text passage is blank. For example, the important point for this demonstration is that sound waves produced from different sources at the same instant can cause constructive and destructive interference. Thus, the language function served here is summarizing. And the final example of a discourse pattern is the following. This blank is needed for blank because it blank. For instance, a closed circuit is needed to light the light bulb because electricity cannot flow through an open circuit. Thus, the language function served here is identifying relationships. In conclusion, collaborative discussion should foster deep thought and critical thinking, should follow a logical progression of thought, and should lead to individual thinking in order for students to engage in the learning process and to construct individual meaning. The use of discourse and communication in the science classroom is inherent to the nature of science, and with thought, careful planning, and practice can be effectively used by the secondary science teacher.